All right, good morning. Thank you all for joining us for our webinar today, Maximizing Success in Manufacturing Facilities, Practical Industrial Hygiene Programs for Safe Environments. Presenting today will be Forensic Analytical's very own Senior Project Manager, Brad Burcz. Brad has a master's degree in Occupational and Environmental Health Sciences. He's a certified industrial hygienist and a certified safety professional with over 13 years of experience in the industry. He also teaches industrial hygiene courses at the University of Michigan and has extensive experience working in the manufacturing, utilities, and nuclear power industries, performing services such as comprehensive exposure assessments, air and noise monitoring surveys, IAQ investigations, safety and industrial hygiene program management, system implementation, regulatory compliance program development, training, and much more. And before I hand it off to Brad, I want to quickly cover a few components of the webinar platform we're using today, GoToWebinar. Everyone is in listen-only mode, but this does not mean that we cannot communicate with you and you cannot communicate with us. As you think of questions that you have for Brad throughout the webinar today, please enter them into the question box in the control panel on your screen. And we'll cover each of those in the Q&A session at the very end of the presentation. And with that, I'll hand it off to Brad.
Thank you, Taylor. And again, thank you everyone for joining our presentation on practical industrial hygiene programs to maximize success in manufacturing. For today's webinar, I'll begin with an introduction to industrial hygiene and its importance in manufacturing environments, and also help provide an understanding of the classical industrial hygiene framework and considerations for designing a sampling strategy. So it is quite sobering to know that approximately 275 people die from occupational injuries and illnesses in the U.S. alone on a daily basis, resulting in 95,000 workers dying in 2017, not from occupational injuries, but from occupational diseases. Expanding that statistic worldwide, there were roughly 3.5 million workers who died in 2017. And sadly, those numbers are most likely higher due to inconsistent reporting, especially throughout the developed world. Even more important is considering that OSHA was created over 50 years ago, and there were over 5,000 people who died on the job in 2018. This provides a really stark reminder of just how important our work as health and safety professionals truly is. So for those of you who may just beginning their careers within EHS, or perhaps are working in other roles like operations, I think it's important to provide a brief overview of what industrial hygiene actually is. So industrial hygiene is both a science and an art devoted to the anticipation, recognition, evaluation, control, and confirmation of protection from those environmental factors or stressors arising in or from the workplace that may cause sickness, impaired health and well-being, or significant discomfort among workers or among citizens of the community. Although the specific field and practice of industrial hygiene was established in 1939 when AIHA, the American Industrial Hygiene Association, was founded, the core principles of which the profession was founded upon have really been around for a long time, all the way back to 400 BC, with Hippocrates identifying lead poisoning in miners. Fast forwarding to 100 AD, Pliny the Elder developing the first respirators to prevent inhalation of dust and fumes. And in 1700, Bernardo Ramazzini, the father of occupational medicine, publishing De Morbis Artificum Diatriba, or Diseases of Workers. Then in 1939, AIHA, the American Industrial Hygiene Association, was founded. Eventually, in 1970, President Nixon signed the Occupational Safety and Health Act, or OSH Act, which was formally enacted on April 28, 1971, leading to the creation of what we know today as OSHA. So when talking about OSHA, specifically in the workforce, there's often an emphasis on safety, and rightly so. But I do think it's important to highlight some key differences between occupational safety and occupational health. Simply put, occupational health focuses on preventing sickness and disease caused by exposures to chemicals or physical hazards like noise, and even biological agents like Legionella and mold. With safety, it's not uncommon to be able to see the hazard. Maybe it's moving machinery or trip hazards or working at heights. However, with occupational health, it's often difficult to see what's in the air that you're breathing. So the industrial hygienist role is quite vast, from whether it's chemical, physical, or biological agents that we're concerned with. We're guided by a core principle, that being any foreseeable risk of injury, disease, or death are never acceptable. If safety engineering and industrial hygiene practices can eliminate the hazards or manage them to an acceptable level of risk. So putting it simply, if it is foreseeable, it is preventable. So why are we focusing on manufacturing today? Well, a number of reasons. Manufacturing is incredibly diverse, right? Each industry within the sector is faced with a myriad of regulations that can change really quickly. Faced with high demand production schedules, and that puts pressure on increasing output, which can be challenging to balance against ensuring the health and safety of our employees. And every manufacturing environment has a high degree of variability in the risks of exposure, ranging from chemicals to ergonomics. For example, if you work in the chemical industry, you might devote a lot of your time to process safety management. Perhaps you work in a coatings facility where you need to spend a lot of your time on air permitting and hazardous waste regulations. Even further still, you work in a plant with highly repetitive hand assembly stations. You may need to spend a lot of your time on ergonomics and prevention of repetitive injuries, repetitive stress injuries. It's also become more and more common to take on the role of the EHS generalist, where in addition to environmental, health, and safety compliance, you might be tasked with managing workers' compensation or even security of the site. We often wear a lot of hats in manufacturing, and it can be difficult to spend the amount of time needed to effectively manage specific risks and challenges. It's also not uncommon for there to be one EHS professional for hundreds of employees, sometimes across multiple sites. However, a well-designed industrial hygiene program can be used in any manufacturing environment. Doesn't matter what you make, doesn't matter the size or complexity of the organization or the processes that you face. So all those challenges can often leave you feeling stuck in the more reactive mode instead of a proactive one. So working towards the development and implementation of systematic means for identifying, managing, and controlling risks stemming from occupational health hazards helps provide a place of employment which employees are protected from all known occupational health hazards, which not only clearly benefits the workers, but also benefits the organization as well. And it does that by reducing costs and liabilities associated with compensable injuries and illnesses, an increase in productivity, not only from reducing lost time accidents, but through the improvement of employee morale and the relationships between unions and management. We all know that the earlier you can be involved to reduce risk, the better, right? Earlier risk reduction interventions will help lower operation costs. Consider eliminating hazards in the design stage as opposed to post-launch. And a formalized occupational health management system or industrial hygiene program makes it easier to anticipate regulatory changes and be able to quickly respond and adapt to them. So the classic industrial hygiene framework. You open an industrial hygiene textbook, you are going to read about anticipation, recognition, evaluation, control, and confirmation. And although this may appear to be a linear process with a starting and end point, it really could not be further from the truth, because this framework is a cycle of continuous improvement through communication and prioritization of risks. So beginning with anticipation and recognition, what's the goal, right? The goal is to identify present and potential health hazards through understanding materials, operations, and processes and environmental conditions present within your company. How do you do that? Well, there's a number of ways, right? One of them being your safety committees. At all levels, safety committees provide information to help identify potential or known health hazards. Nobody understands the job they do better than the person doing the job. And when you have hundreds of people with diverse skill sets and responsibilities, they often share perspectives that you simply can't see or grasp. You can also perform site walkthroughs and surveys, right? These comprehensive assessments are one of the best methods for identifying health hazards. If you've ever had to perform a chemical inventory at one of your facilities, there can be a myriad of products, often in the numbering in the thousands, right? And maintaining an accurate chemical inventory and having a robust chemical approval process will provide you with detailed and specific information on the chemical hazards and allow you to earlier identify and recommend controls. We talked previously about the importance of early interventions. So your involvement as an EHS professional in equipment and design safety reviews is absolutely critical. So that'll help ensure that new or modified equipment and facilities can be as safe as practical and allow for engineering controls to be built into the process early on. Because the earlier the involvement, the better. Also, say you're new to the organization and you'd like to get a quick overview or an easy overview of what your employees are faced with in their day-to-day tasks. You can look at an employee training matrix. That can tell you, well, maybe you have employees that work with asbestos abatement. Perhaps you have a lot of welders and they have hexavalent chromium training. All of your employees should have a hazard communication program, right, which ties in directly with your chemical inventory. Perhaps there's a hearing conservation program established, so you know that performing noise exposure monitoring is going to be critical. Other standards and work processes with common agents of concern include lead and silica, and even heat stress. So the evaluation piece, right? What's the goal? Goal is to achieve a thorough understanding of exposures and the risks that they pose to allow for prioritization of your control efforts and increasing assurances that the most important, i.e. highest risk exposures, are being controlled first. Well, how do you do that? Right? Consistently applying an exposure assessment strategy. An exposure assessment is the core function of industrial hygiene programs and provides the foundation for ensuring employee exposures are properly characterized and managed. What does this look like? Right? Within the field of industrial hygiene, exposure assessment and risk assessment are inextricably mixed such that they can't be reasonably separated. So what steps do you need to take to ensure that your exposure assessment strategy is successful? And it may look, again, that this is linear, but it really isn't. It is a cycle of continuous improvement. We're beginning with your basic characterization, followed by performing your exposure assessment with the goals of defining similar exposure groups, which we'll discuss in more detail here in the next slide. Defining exposure profiles relative to some occupational exposure limit, and ultimately making judgments on the acceptability of those exposure profiles. This often results in the need to gather further information, evaluate and implement controls, and then reassessment. The process never ends. right? Once you've initially characterized, performed exposure assessments, you can then characterize your risks, prioritize them for control, and reassess to confirm the effectiveness of those controls. Beginning with basic characterization, right? Your goal here is to identify the health hazards within your work environment. And you can do that a number of ways. And primarily, you want to understand and organize the information available to you on how your workforce is organized, staffed, and assigned tasks through job classifications or job titles. Understand what chemical, physical, and biological agents are in your work environment, and what are the chemical and physical properties of those agents. Once you've identified the chemicals, you can then understand the health effects that are associated with excessive exposure to those agents. You can define the occupational exposure limits for each agent and identify what you consider to be significant sources of exposure and how the workers interact with them. You can do this without needing data to right away from a purely qualitative perspective, right? Looking at the source of exposure, the path that it would follow until it ultimately ends up at the receiver or the worker. Historical exposure data at this point can be very useful to identify combinations of processes, personnel, and agents assessed in the past and make sure that they haven't changed. So health hazard evaluation, right? In your exposure assessment, what are the goals? Ultimately, it's identifying similar exposure groups or SEGs, defining exposure profiles for the SEGs relative to their exposure limits, and again, making judgments on the acceptability of those exposure profiles. So establishing SEGs, again, similar exposure groups. What are they really? SEGs are groups of workers having the same general exposure profile for the agent or agents being assessed due to the similarity and frequency of the processes and tasks that they perform and the materials with which they work. SEGs can be based on any combination of job position, processes, tasks, and or individual agents. And individual employees may be members of more than one SEG. And you can establish these SEGs both qualitatively and quantitatively, or both. From a qualitative perspective, think more observationally, right, based on information that you obtained during your basic characterization. Exposure data is not required at this point, but again, historical data can be very useful. From a quantitative perspective, or really data perspective, that will allow you to take a look at the exposures of many workers that have been measured through sampling, and then further refine your SEGs based on an analysis of that exposure data. So now you're ready to start developing some of your exposure profiles, right? And your exposure profile is an estimate of the exposure intensity and how it varies over time for a similar exposure group. How do you do that? Again, by characterizing your risks. It can be done quantitatively or qualitatively, like we had previously discussed. And once you've defined your exposure profile and selected the appropriate exposure limits, each SEG can be judged acceptable, unacceptable, or uncertain. So what does a characterization of risk really look like? And how do you prioritize the risks that you've identified? Similar to a safety risk assessment or risk matrix, where you're plotting likelihood of an incident occurring relative to severity if that incident were to occur, a health risk assessment can be characterized in a similar manner. But more specifically, you're going to want to look at the agents that are involved in providing an estimated level of exposure, the severity of those health effects, and the degree of certainty that you have regarding the exposures and their health effects. A simple risk matrix can make this very easy, where again, instead of a pure severity versus likelihood, you have your exposure rating relative to your health effects, right? And that'll provide you with a risk ranking, right? Again, it's exposure rating times health effects rating. It's really important to remember, though, that this matrix is just a tool, right? Especially when used without good data. So it is absolutely critical for you and your organization to agree on the definitions and terms that are used and define what your acceptable level of risk is. We all know that there's no such thing as zero risk. There's only acceptable risk. And this process can be kept as simple as that, or can be made even more complex by incorporating other variables such as uncertainty or the need to gather more information. So taking it one step further, right, and incorporating uncertainty to help you further rank and prioritize these risks. Some examples here, identifying a few segs, correlating the processes that are involved, the process or process involved within that seg, the agents of concern, their exposure, duration, and frequency, understanding what PPE is currently required or being used, any engineering controls that are already in place, defining the occupational exposure limit or OEL for that agent, and then again, ranking your exposure rating, the health effects rating, and the degree of uncertainty to provide you with an overall risk rating, right? And don't worry about the numbers themselves. You could use, instead of 1 through 5, you could use 10 through 100. The point is that this provides a consistent means to identify what is the highest priority. It is very common to encounter the need for further information to allow you to make a confident decision about exposure profiles and their acceptability. But regardless of the approach that you take, your priority for taking action should depend always on the highest potential health risks. So judgments of acceptability, right? We've worked through our basic characterization, we're performing our exposure assessment, we've characterized our risks, and now it's time to determine their acceptability. They'll either be acceptable, unacceptable, or uncertain, and that's okay. The more acceptable, the more confident you are in your decision. The more uncertainty that you're faced with increases the need to gather further information, oftentimes through additional monitoring and collection of data. And a more comprehensive definition for acceptable, unacceptable, or uncertain would be that acceptable exposures and acceptable judgments should be made when the magnitude and variability of exposure is low enough that the risks associated with the exposure profiles are low, and when there's high confidence that the probability of adverse health effects is minimal. Acceptable exposures may need no further action at that time other than documentation until it's time for a reassessment. However, further information and new exposure monitoring data may still be collected to help verify the acceptable judgment and ensure exposures remain well controlled. Uncertain exposures, making that judgment when you can't classify the exposure profile as acceptable or unacceptable, can occur when the magnitude or variability of exposures are not very well understood, or when there's a lack of health effects data, which can make it difficult to establish an OEL. Uncertain exposures should be resolved by putting them on a prioritized list for further information gathering or collection of exposure monitoring data, or recategorizing them as unacceptable and warranting further evaluation and control. An unacceptable judgment is one where the average exposure, TWA, or the upper extremes of the exposure peaks were high enough to present an unacceptable risk, i.e. the exposure exceeds the OEL. Unacceptable exposures are to be put on a list for control, and that list should be prioritized such that the higher exposures to higher toxicity agents should be controlled first. So confirmation and control, right? What's our goal? The goal is to provide a reasonable assurance of worker health by controlling or reducing potential workplace hazards to the lowest possible level, right? And how do we do that? Well, it's the hierarchy of controls, right? Unacceptable exposures must be controlled, and the methods for prioritizing them can use the same scheme as prioritization for your SEGs and additional information gathering. This hierarchy, similar to others, right, begins with elimination at the top, substitution, going down further to administrative controls, and finally, personal protective equipment, right, the absolute bottom of the pyramid. Elimination of the process, equipment, or materials that give rise to the hazard or allows the exposure to actually happen is obviously the most effective way to manage and control your risks. Administrative controls can be very useful as well, because oftentimes there's a need for a combination of controls, right? Engineering in concert with administrative controls, work practice controls, and PPE. And they'll all depend on the magnitude of the health risk, right? Their technical feasibility of implementation, their economic feasibility, how reliable the controls can be, what the worker acceptance is, including negative impact on worker well-being and productivity. What are the consequences of control failure that needs to be thought through? How intensive is it to maintain these engineering controls? Do they introduce any new safety hazards or environmental hazards? And could they be associated with creating new process safety hazards? So prioritizing your controls, right, for your implementation. The hierarchy, again, it's based on reliability and effectiveness of your control strategies. Initially, the SEGs that are judged unacceptable should be quickly controlled. And that can often be done through administrative controls, work practices, and use of PPE. That can then provide you time to seek out more permanent controls through engineering means. Regardless of the level of control or the type of control that you use, the effectiveness of them needs to be validated through exposure reassessments. So reassessments, right? It's very important to keep your exposure profiles and SEGs up to date and ensure that exposures continue to be very well understood, and having a formalized industrial hygiene program will help you to respond to these changing priorities. Even when your SEGs are seemingly stationary or unchanged, collecting that additional data through periodic monitoring can expand your data set and allow for improved and refined judgments. And comprehensive reevaluation of exposures can further verify that exposures previously deemed acceptable remain as such. So exposure should always be remonitored whenever there is a change in things like the process or operation that are used, or maybe there's been modifications made to equipment or machinery. Oftentimes there may be big increases or decreases in the number of workers performing the same or similar work tasks. And if information regarding the health effects of an environmental agent or its exposure limit changes. As a very basic example, you can set monitoring frequency based on your exposure risk ratings, right? Relative to the OEL. So where you're confident that exposures remain below, say, 10% of an OEL, it may be appropriate to remonitor every other year. If exposures are between 10 and 50% of an OEL, perhaps it's every 9 months. You get 50 to 100% of the OEL, maybe it's every 6 months. This is in addition to regulatory programs that have monitoring requirements, right? Because those may be previously defined for you, and you need to make sure that you're following what the standard has set forth. We talked about a lot about the need to collect data, right? And we collect that data through sampling. And when putting together a sampling strategy, there's a few really important considerations, right? Because, a sampling strategy should really go beyond ensuring compliance to minimum government requirements, right? And the goal of your strategy should be to reliably detect poorly controlled work environments. So what should you consider? Right? Sampling time, right? Making sure that your measurements are collected in accordance with the OEL's averaging period. More often than not, that's an 8-hour time-weighted average. There are shorter duration periods that can be required to assess compliance to short-term exposure limits or STELs, 15-minute increments. If your monitoring duration is less than the required integration period or less than the full length of exposure in a workday, then your accuracy may not be so good when you are deeming these exposures to be acceptable or not. It's also critical to follow correct air sampling methods. Your air sampling methods should be selected and conducted in accordance with appropriate NIOSH and OSHA analytical methods. And another note on that is it's really important to have a good relationship with the lab that you're using for analysis. It's oftentimes these labs, which should always be accredited through AIHA, may have vetted modifications to those methods, and they will work with you and help you understand why you may need to approach this specific sampling initiative a little bit differently. So lastly, one of the things that having a formal industrial hygiene program will do for you will make it easier to integrate new or changed or existing regulatory programs, right? Because an IH program will enable proactive risk management, like we talked about. It'll help ease compliance with your regulations, and it will do that through a number of means. Right? One of them is having a systematic risk assessment process to identify areas with specific agent hazards, helping to prioritize control measures to comply with the exposure limits. It'll also help with easing implementation of effective monitoring and sampling strategies and align with specific requirements of any regulatory standard that requires exposure monitoring as a part of it. Also, record keeping and documentation, where documentation of your exposure monitoring results, your exposure assessments, and risk characterization are all critical elements for demonstrating compliance during any regulatory agency inspection, which ties directly into improved communications with regulatory authorities. Because you now have a structured approach to exposure management, which will facilitate effective communication with the agencies during inspection and provide evidence of compliance and a clear understanding of the measures that are currently in place to address agent-specific needs standards. And finally, the success of this framework, right? The anticipation, recognition, evaluation, control, and confirmation really is not, you can't be successful as just one individual, right? It truly does require, a team. It involves engaging with other groups and departments, from maintenance to engineering to operations, right? And working together will truly result in a successful application of this industrial hygiene framework. And at this point, I appreciate everybody taking the time to listen, and I would like to open it up for a Q&A.
Thank you, Brad. We've got a few questions that have come in so far, and just as a reminder to folks, you can enter them in the question panel in the GoToWebinar platform. Submit those there, and we will shoot them at Brad here right now. But so far, we've got a few that have come in. We'll start with this first one. Where can I go, or what resources would you recommend if I wanted to learn more about exposure assessments for industrial hygiene program development?
A good question. I would recommend absolutely AIHA. They provide a wealth of resources. Oftentimes they provide short 15 to 20 page guidance documents or white papers. But the true holy grail of exposure assessment strategy is provided by AIHA. It's a 600 or 700 page book that takes what we had really summarized here today and expands upon each element in great detail. It is a critical resource if this is something that you're looking at establishing within your company or organization.
All right, and the next question we have is, what's one of the biggest challenges that I might run into if I want to implement this at my own company?
Sure. I would say the number one challenge, and we kind of talked about that at the beginning of the webinar, is providing an education on what industrial hygiene truly is, right? Helping to separate it out from safety. Not that one is more important than the other, but when you're talking about EHS or health and safety, management or leadership is more than likely thinking about safety. So helping them understand what industrial hygiene is, the H part in OSHA, so to speak, right? Occupational health can go a really long way in being successful.
Thanks, Brad. And it looks like we don't have any other questions at this point, but we'll give folks just another minute or two if they have any more questions. We've still got some time to go over those. And if you go to the next slide, Brad, he's also put his contact info there as well. If folks have any questions they'd like to ask Brad directly, you can reach out to him. Right there's his direct number and his email address. We will also post a recording of the webinar from today on our YouTube channel and send out a link to that to all of the attendees that you can share externally as well. But it doesn't look like we have any other questions that have come in. So with that, I think we'll wrap it up today, unless you have anything else you'd like to add, Brad.
No, just again, thank you all very much. And please take advantage of the contact information. I'd be happy to talk to you about this or anything else related to industrial hygiene. I know that this is a pretty comprehensive topic and covers a lot of ground. So if there's something that you think of later on down the road, just please always feel free to reach out.
Thank you. And thank you all for joining today.